So here we go, question 11. Given that the integral from 2a to a of 10 minus 6x dx is equal to 1, find two possible values of a. So we need to do the integral. So write down the constant, add 1 to the power, divide by the new power. Write down the constant, add 1 to the power, divide by the new power. Between 2a and a is equal to 1. Substitute in our limits, so 10 lots of 2a minus 3 lots of 2a squared minus 10 lots of a minus 3 lots of a squared is equal to 1. So let's tidy that up because we've got a quadratic there. So we've got 20a minus, be careful, 2 squared is 4, so it's minus 12a squared minus 10a, minus minus makes it plus 3a squared equals 1. Tidy it up, so we've got 10a minus 9a squared equals 1. So 0 equals 9a squared, because we want our quadratic to be positive and equal to 0. Factorise, if you need to use a grid, do so, but it looks like this is going to be 9a and a minus 1 and minus 1. Just check that. 9a squared minus 1 times minus 1 is plus 1, minus 9a minus another a is minus 10a. So that checks. So a equals 1/9 or a equals 1. Right, so that was just having the confidence to start the question and do the usual things. Integrate it, substitute in the limits, and then solve what comes at the end. So that's part A done. Part B, labelling all axes, intercepts, sketch the graph of y equals 10 minus 6x from 0 is less than or equal to x is less than or equal to 2. So B, 10 minus 6x, so it's going to come down fairly steeply, that's 10. X, that's the y-axis, 0, label a line, y equals 10 minus 6x. So at y equals 0, 10 minus 6x equals 0, so 10 equals 6x, x equals 5 over 3. So that's that point there, 5 over 3. So that is that done. Use a ruler, etc. when you're doing it for your axes and your line. And we had the y-intercept using y equals mx plus c. For this bit, from here, y equals mx plus c, the constant there. And then over here we worked out the roots because we know at the roots happen when y value is 0. Substitute it in and work it out. Okay, part C. With reference to the integral in part A and the sketch in part B, explain why the larger value of A found in part A produces a solution for which the actual area under the graph between A and 2A is not equal to 1. Between A and 2A is not equal to 1. So, we're looking at part C. If A equals a ninth, say well with reference to the integral in part A and the sketch part B, explain why the larger value of A, so it's the larger value of A, that's what I hadn't read carefully enough. Yeah, it always comes back to bite you if you don't read it. Well, not always, but quite often if you don't read it. Question, so it's the value of A, which is 1 then. So when A is 1, when A equals 1, the limits are 1 and 2, A and 2A. So I'm then looking at this section of the graph, 1 up to 2. So this section is going to be positive and this section is negative. So let's read the question again and see how we're going to answer it. State whether the area is greater than 1 or smaller than 1. Produce a solution for which the actual area under the graph between A and 2A is not equal to 1. State there is greater than or smaller than 1. Well, the shaded area, therefore shaded area is greater than 1, because the bit to the right, so if I call this 1 and this 2, area 1 is greater than 1 and area 2 is negative. And when you combine the two, you get 1. So area 1 plus area 2, which is negative, will equal 1. I hope that's clear.